So we're going to go ahead and simulate these in a moment. I just want to clarify what I said in the previous video was that the attribute is being copied over here, but in reality it's not. If you check here in the geometry spreadsheet, we don't actually have the orient attribute. We do have the velocity, and it's not there either. So yeah, actually it's using the orient attribute to transform, and you can see that when you turn it off and on there, right? So yeah, here these are attributes which are being copied. This, if you notice the formats there, so we've got a star, which means everything, copy everything, and then when we use this little triangle, this means except for, so it's going to copy everything except for or other than the velocity, alpha, normal. So in fact it's not copying the orient onto the points, but it's using the orient, as you can see, to transform it. One more thing we need to do is pack these. So pack an instance. So now if you check the points number, we've got 123,000 points. So if we pack them ready for bullet simulation, which is what we're going to use, we'll take a look, and that'll be just 12 points, taking up much less memory, and it will simulate quicker and it will work with bullets, right? So as we are in Houdini 18, we can go ahead and use, in the first week we used just the standard DOP network. As we're in Houdini 18, we can use the bullet solver, RED bullet solver. If you're running an older version of Houdini, you can use the DOP network. I just want to show you this as well. So you can just use the same, basically the identical setup from week 1. So yeah, we got this bullet solver. So basically the idea of this is that Houdini have packed everything that you need to do a bullet simulation into this handy node, this high level node. And then you've got all the typical parameters, options in here, constraints, you know, it's all set up for you. Guided simulation, which is a new thing which was added for Houdini 18. And so yeah, basically you can just plug it in and it's good to go. We'll visualize that. Let's drop a ground plane, head in here to ground plane, and we should just get a simulation right off the back. There we go. See how fast that is as well. So as you can see by this padlock, so this is, it's like a subnet. You can make one yourself. Sub network, it's basically the same thing. Whoops. But it's, the idea is you know, you can go inside, and this is another geometry network. So it's just a way of organizing, and you can build your own personal tools like this as well. If you're doing, for example, like this, we could put all of this inside a subnet, and you know, you put your geometry in one side and your points in one side, and it spits out your geometry ready to simulate. But getting off track, this is something that the guys at Side Effects built, and if you can even dive inside yourself here. Well, actually, if you right click and go allow editing of content, you see this open, and then when you go inside you can see how it's built up. You can see this maze of nodes, but in here we've got lots of different stuff going on for, you know, for your constraints and setting up different parameters. And in here somewhere, I don't know if I can find it, I think it's there. Yeah, we've got the DOP nets, the same as that we created in week 1, and we can go inside the DOP net, and we've got the bullet solver, rigid body solver, you know. So I'm just going to right click on this and go match current definition, so that will set it back to, you know, the default mode. And let's see, if we check the real-time toggle so that it plays in real time and not super fast, let's watch that. Okay, so already pretty good. let's see, what could we do? I'm going to drop the ground plane down a little bit. Let's see, to drop that down a bit. Let's just zoom in so we can see what we're doing. Again, if you remember in the previous week, I believe, yeah, we used the time scale in the flip solver. So we can do the same thing here. So we get a nice slow motion effect. Just drop that to 0.1. Let's take a look at that. And you can see the variation in velocity as well. I'm going to turn off the ground plane, the grid. You can see they don't, some kind of go up a little bit and some drop straight away. See that? Okay. What else could we do? We can take a look at the forces. No, gravity is fine, I think, as it is. Let's take a look at let's see, friction. No, we don't. That's the bullet object. Yeah, let's add some density and friction so they kind of don't move about so much. There we go. What else? I think that's pretty much it. We could, if you want to, if you remember in the first week, we also used the pop spin. To do that, something I did earlier, if you double click and go inside, or if you remember, you can press I to go inside. Here, there's a note to tell you. So we're kind of deep inside that subnetwork now, and we're actually in the .NET there, and it says wire pop forces into the force output here to output per point forces. So we can use all of the pop things to affect our RBD simulation here. So if you press tab and then pop, oops, not pop, yeah, you can use all of these to, I think all of them, to affect your simulation. So we're going to use the pop spin. If I can find that. Where are you? Not pop steer. Scroll down, pop spin. Okay. And the axis, let's change the axis a bit. And the speed, let's put it up to 200. Go back out here so we can see the result. You see that? We just get a little bit of a change. It's a subtle difference, but they do start to rotate. And they do continue spinning after, which looks a bit weird after, but for our simulation, we're not going to be, after the initial splash, that's enough then. We're not going to watch them kind of rolling slowly afterwards. Let's bring up these sub steps just to get something a bit cleaner. And I think that's it. We're good to go with that.